Few things make a machinist happier than a facing up with perfect cross-hatching. But in that shot was Marcus's mill, not mine. To make sure I can do that, I had to scrape my entire Z-axis. So that means scraping the machine-based column mounting face to the spindle block swivel lock. That sounds made up. From experience, I know that the spindle is leaning forward towards the operator a little bit, and this is going to leave some ridges between passes sometimes, and importantly, it's not going to leave cross-hatching in one direction of travel. So we're going to have to play detective Scrapist to figure out what's going on, what's causing this. It could be that the column is leaning forward, not good. It could be that the spindle is leaning forward and the column's square, also not good. It could be both, also not good. Because the spindle head can't be measured without being mounted to the column, and the column can't be measured for squareness without being straight, we started by making the column Z-axis ways straight and parallel. Scraping the Z-axis ways is very much the same in principle to all the other dovetails that we've done so far, so that means step scrape the flat ways, finish scrape the flat ways, scrape a dovetail flat, measure for parallelism and step scrape the opposing dovetail, and then finish scrape that dovetail, and then you're done. So there was no obvious way to really hold the column in place to be able to measure it on the surface plates. Like, there's nothing on the back, it's just paint. And I may not look like the kind of guy who would use a painted surface as a precision reference, but you'd be wrong. No, I'm joking. So we started thinking about holding it like a rotisserie by making like plates or something to go on both ends that we could level it out with. But fortunately, Marcus was rude enough to scrape paint off of my machine without even asking, and he discovered that there was actually a ground surface on the back of the column. So we can use that to scrape in some pads, 3 pads, which we can use to level out the flat ways to be close to parallel, and that minimizes the amount of work that we have to do to get them actually, within tolerance. It's all just looking awful, isn't it? Although the surfaces on these flatways looked more like files than actual machine guideways, they were actually quite straight. They were within a thou over their entire length. So that made our life pretty easy. They did have a lean in the other direction, which doesn't matter, but me being me, I couldn't help myself and I just had to eliminate that as well. So I still step scraped that in all directions, and now they're fully flat and fully coplanar as well, which is useless really, but makes me feel good. Then you just finish scrape and you're done. In this case, I did have to use a smaller dovetail straight edge than covers the length of the entire guideway, which usually is a big no-no. Like, you can't make a precision flat surface with a small straight edge, but we're step scraping this. So we've already confirmed that the entire length is flat. What we're doing here is really just printing it to improve the quality of the surface finish rather than the geometry of the average of the surface. Does that make sense?
The dovetail, however, could not be easily made straight and flat without a straight edge that could span its full length, and Marcus's long one had developed a bow over time. I don't want to mess with Marcus's precious straight edge, that might make him uncomfortable, so I asked him to do it himself, which was naturally an offer he couldn't refuse amidst his packed day of dirty fabrication work. When I got my turn at the long straight edge, I went straight to scraping and printing to make one dovetail flat. As always, start by checking for, and if necessary, removing convexity.
Alrighty. Alright, now, at this point, we've done... Okay, quick, no! All right, at this point, we have done the flatways and one dovetail. Now we need to do the other dovetail, but we need to make sure that it's straight and parallel with the existing one. So just like usual in the previous two videos on this, Hoffman rollers micrometer, measure at intervals along it, and then it's essentially like step scraping on one axis along that length. Make sure that they're all the same distance apart, because we've already got one that's straight, and if you just make the other one the same distance apart all the way along, then they're parallel.
I only had access to a thousandths micrometer, and we're working in 10,000ths, so I was reading between the lines here. Eventually it came in close to parallel, and then you can use the straight edge to finish scrape it.
The flatways on the Z carriage looked suspiciously unconducive to squareness and rigidity. So when I printed it up, they were surprisingly good looking. I'm like, what? How? How can they be that good? Nothing on this machine from the factory has been this good. Stared at it for a while, then Marcus comes over and within 5 seconds realizes that the surfaces are convex. So as I've gone on about, every time I've started a new surface on this machine, check for convexity, and I didn't. So putting it back on the column and putting an indicator on it to measure for that rocking, we got over 1 thou of rocking. And there was even a little bit of twist in there too. That's not good for rigidity. But this effectively acts like a pivot point where the head can rock on those flatways. And this does fit the symptoms that I was experiencing way back when I was running this machine, where when I locked the gib, I would notice the head lift up, which is kind of normal, but it was a lot. What we actually want is to just have pads on the end of the flatways and just a relief in the center, just like we did on the XY saddle as well.
Dealing with the convexity of the carriage flats is pretty easy at this point. Just rough out a bunch of material in the centers to make 4 pads of contact, then finish scrape those pads to make sure that they're in good contact.
Interesting. Ooh, that's pretty good. I like you. Look at that.
And better than I expected.
It's not even a fraction of a tenth. Don't you like you?
Yeah, those flats were brutalized by whoever did scrape them at the factory, so it was pretty hard to get them to get full coverage. Fixing these flatways will make a huge difference to the performance of the machine, because the head is, the thing that holds the tool. If there's no rigidity there, you're always going to experience a lack of rigidity. This isn't case closed though. So far we've only improved rigidity. We've still got the mystery of the not square Z-axis. Now a lot of people think that just like tramming the head is going to fix all vertical problems, but most people are wrong. There is good chances that the column isn't sitting straight, because where you might use precision scraping to mount the column to the base, these guys have just banged it together with a 7-inch disc sander as a precision matching technique. But we'll talk more about that in a sec. Hello. You might be thinking about how sexy I look, but it's not because of me. It's because of how easy and elegantly this E7Plus 4-legged standing desk by FlexiSpot can raise and lower my big, heavy parts. They sent it to me to demonstrate how stable and robust a 4-legged standing desk is. Personally, I get by with 3, but that wouldn't make sense for a desk, would it?
Okay, enough of that. The extra legs increase stability and lifting capacity to 540 pounds. That's 244 kilograms, which is more than the Uplift V2. Not only that, the E7 Plus can lift up to 52.57 inches, the highest 4-legged standing desk you can buy. It also comes with a 15-year warranty and a 30-day risk-free return service. Not only that, it's budget-friendly compared to other standing desks on the market, which cost over $1,000. Now, I've actually already got a standing desk and have for years now, and I love it. It really is a great thing to have if you work at a desk a lot.
So instead, Marcus and I are going to put this more durable one in the workshop and really put it to the test. So the question is, can I do scraping on it?
Actually, yes you can, and I'll be using it a lot for the rest of this video.
Compared to the competition, who usually costs well over $1,000, the FlexiSpot E7Plus gives you a budget-friendly option for the same experience.
FlexiSpot is currently running a special 9th anniversary sale up to 50% off, and there's also a chance to get a 100% free order. Don't miss out. Shop now, and if you liked it, leave a note saying Mark Super at checkout and use my code YTE7P50 to save an extra $50 off and get your own E7 Pro standing desk today.
FlexiSpot offers special discounts to medical, students and graduates, teachers and military across their entire website. So click the link below and don't miss out on your chance to get a great deal on your own E7 Plus 4-legged standing desk. Now I want to say thank you to FlexiSpot for sponsoring this video. Now let's get back to it. So we've got the carriage flats sorted. Now it's time for the dovetails, and these appeared to be the world's first chiseled dovetails. So I figured, when in Rome, no, I'm joking. And before even bothering to print up that fixed dovetail face, I just went straight to scraping it to give it a more usable finish that prints up nicely. Then, you know, as always, remove convexity in the center, and then just print, scrape until you've got even coverage. Next was the opposing dovetail, which we covered in a lot of detail really in the previous video, scraping the XY saddle. Talked about the gibs a lot. Even my mum knew what was going on, kind of. So go check that video out if you haven't already. But basically you want to get the sliding face of the gib concave. You want to get the mating face of the saddle to the gib concave. And you want to make sure that the gib doesn't travel in too far and run out of travel. And you also want to make sure that the whole thing doesn't rock side to side once you've got the gib in place.
This time, thanks to the amount of material I had to remove in the dovetails, the gibs completely ran out of travel, which means I have to put material back on somewhere. Last time this was done with the turkite. This time, I don't have time to stop and get turkite glued to the gib, but that means I also don't have time to machine a new gib. But there is one other heinous way of fixing this issue that I didn't mention last time, by gluing shim stock to the non-sliding side of the gib, or in this case, a Starrett 10 thou feeler gauge. Marcus urged me not to. He called me an animal if I do it. So I was faced with a question. Am I an animal? Yes, I am.
Uh-oh. Ooh. That's not good.
For real though, I'll fix this up properly later. Because the head can swivel, we don't need to worry about getting the dovetails to sit in any particular squareness like we did with the X and Y saddle. Just make sure that the gib fits and the carriage doesn't rock side to side.
Hell yeah, Axel. Now while reorganizing the shop, the spindle head took a tumble and fell flat on its face. I don't know if these controls are going to work, but that's a problem for future Christian. For now, we scrape. The mating face of the head is a little bit different to all the other ones we've done so far. This one rotates rather than slides and spends most of its time, or ideally all of its time, still, rigid. Spring washers. Useless. NASA looked it up. They looked it up. They Googled it. NASA Googled whether spring washers are any good. Nobody can Google like NASA Googles. Now the carriage face has a boss which supports the head as it's swiveling, which means that you can't print that face to, get it flat. It's in the way. And Marcus told me that I should make a donut plate to be able to scrape that, but I had no donut. I just scraped the head first and used that as a master.
To do this, we can check for any rocking to show convexity, then print and see what we get. And what we got was predictably mediocre.
Oh. Oh, damn. I thought I was reading something, but I'm just bending that plate up and down. Chat, what have we got? Not good. Okay, that could be worse. It's interesting, there's some contact here in the middle, just kind of what you would expect. And otherwise the contact is around the outsides. There wasn't a lot of rocking when I measured it. So I think that's just a case of scrape that until the whole thing is blue. Oh, beautiful. Ah, see, this is too high. Perfect. This has been the smoothest, most productive scraping job I've ever done. Every time it's just looking better and better. No setbacks, no nonsense. Hell yeah, this is good. So after carrying the heavy rock back and forth a million times like a slave, I eventually had a flat surface for a master. The carriage, when compared to our new master surface, was extremely convex, which meant Mr. Detective Scrapist had a lot of back and forth to do to get that somewhere sane.
I chose to press firmly on the swivel pivot point when printing to emulate the conditions it'll be under when assembled. Once the convexity was all gone and the surface was getting fairly stable, I left it there because this is the face I'll use to adjust the squareness of the spindle in the forward and back direction. So going too far making this surface all shiny and nice might just be a waste of time.
Finally, this is the part that you've all been waiting for, because we bring it all back together now, but I've been waiting for this because I get to talk about this.
In manufacturing precision vertical mills, the interface between the column and the base is very important for holding the Z-axis perfectly square to the table, and to keep the Z-axis rigid as it deals with the cutting forces, acceleration forces, and gravity. So the two mating faces are scraped to match each other very well, to have plenty of points of contact and to transmit the load through. In the case of the Optimum MH28V, we're treated to an expert 7-inch handheld disc sander job.
This machine cost me about $3,000 in 2017, so that's like $99,000 in today's money. For that price, honestly, you can't expect much more than that, really. And also, I'm sure the poor Chinese guy that did this work didn't like doing it. I'm sure he hates doing such barbaric work, but it's made to a price, and to be fair, he did a pretty good job. I mean, I later realized that it is faced first, and then he's mostly just taking out material in the middle to make it concave. Still, pretty good work.
The biggest issue with this is that the contact points, yes, might be few, but more importantly, might be in bad spots. Just like the convex Z carriage flats, contact in the middle of the face makes it far too easy for the whole column to pivot forward and back. And that's bad.
In an act that brought me the closest I've ever been to Plato's world of perfect forms, I used the most perfect square I've ever touched. Made from granite, this square, Marcus tells me, is worth more than me. So don't drop it, is what he's saying basically. Thankfully, this monkey managed to control his subconscious chaos and safely handle the perfectly square rock without mishap.
I'm scraping the mounting face of the base to be fairly flat, but not perfect. It just doesn't need to be. Then it's a very simple matter of matching the column to the base.
It was not as simple as expected. I mean, I've had a harder time scraping before, but for a face that's just supposed to sit still, I'm surprised how easily I ended up just going in circles. Firstly, that disc sander job meant that I was roughing out about 1 millimeter of material, which is a lot for scraping. So this ended up being a desperate 2 AM job. And then when it came time to making the fine adjustments to get this thing sitting square, Marcus told me that it would be a delicate process. But I found myself actually going pretty much full force, roughing out material, putting it back on, and measuring no change in the alignment at all. In fact, it got worse in some cases. Thankfully, Marcus showed up on the weekend and set me straight.
Jeez, 5 thou out in the x-axis.
What I was doing wrong mainly was, well, you don't want to bolt up the column, check your squareness, and then use the print that came from that bolted up state to scrape. Clean that off, print it up without bolting it down. You want its resting natural state and use that to print up and scrape wherever you need to scrape to make adjustments.
Matching in the column to the base makes for a great upper body workout, especially if you end up doing this about 50 times in a day. The column needs to be squared up to both the X and Y axes, so 2 measurements are taken, and then you obviously need to scrape whichever parts of the mounting face you need to lean the column towards square. Marcus told me this would be rather delicate work because of the small size of the mounting footprint. I mistook that for meaning small, light scrapes, but what I'm realizing is that he meant the process is about delicate observation. Otherwise, scraping was violence.
In the end, we got the column to sit 25 micron over 200 millimeters in the left to right squareness and 10 micron over the front to back squareness, which is actually perfect for the front to back because when you put the head on, that will lean it forward. And it did, in fact, lean forward to come in perfectly square. Now that we've got the column squarer than a civil engineer, we can turn our attention to the spindle. We had to do it in this order because if we did it in the reverse, we'd be setting the spindle equally out of square by the amount that the column was.
Now this one obviously requires that you put the indicator in the spindle so you can sweep it across the table surface. I'm not looking to measure the side-to-side alignment, or what you'd call tram. I'm just looking to measure the nod, the front to back. So I check the difference between the front and back, take the head and carriage off, and bias scrape one side to adjust the alignment. If I was planning to use this swivel feature, this would be the wrong way to do this. This face should sit parallel to the column, so when you use the swivel feature, the tool doesn't go out of square. But I just prefer to think I've made a shallow compound angle head.
So this is the part where I was supposed to tell you guys about how I'm going to get the spindle nod to be square by scraping this interface. But I'm not going to have to because it's already perfect. It's literally perfect. And I did scrape this face, like that's not factory. I just scraped it to get it stabilized and now I was going to adjust it. But I've already got it perfect. It's a Christmas miracle. Obviously I was going to show you the process of scraping this to get the nod in the spindle sorted. What I was going to do was, scrape the top to make it lean that way, or scrape the bottom to make it lean forwards more. Don't have to though. I might just scrape it a little bit to get more points of contact, but otherwise we're there. It's done. It's done. On the Muck Super Patreon, you'll be able to watch a much more detailed and extended cut of this show. You'll also be able to download the textures and 3D models used to make the show. And of course, you'll just be truly helping to support the project and keep the channel going. So any support would be much appreciated. Check out the previous 2 videos in the series on scraping. If you were confused here, they might clear some things up. Otherwise, thank you for watching.